Welcome to the most awaited lecture of Part C revision of Advanced Mechanics of Solids. We hope the Part A was pretty useful and you have made good use of it. Now obviously Part C is a bit complicated. We have tried to make it pretty simple. So since this is a lengthy module, we have divided the topics into some multiple lectures. Presently we are uploading the torsion of non-circular prismatic shafts, in which we are discussing Venant's method and Parentals method, and we are solving for both circular and elliptical sections. So we request you to watch the video with your pen and papers ready and parallelly practice while watching the video. Thank you. Let us analyze the difference between torsion of circular and non-circular cross sections. So you might have learned in circular cross sections we had taken an assumption there is no warping. So in circular shafts there will not be any warping, whereas in non-circular shafts warping occurs. I will explain later what is warping in detail. Now the second difference, for circular shafts we have the equation T by J is equal to tau by R equal to G theta by L. So from that tau is equal to TR divided by J, which means tau is proportional to the radius. So what does that mean? That means the shear stress will be maximum at the outer surface of the circular shaft. Whereas in non-circular shaft, here I have not mentioned non-circular in general, I have mentioned in specific for a square shaft or for a rectangular shaft, shear stress will be 0 at the corner or edges of the shaft. At the outer surface, if you take the corner or edges of the shaft, the shear stress will be 0. So if you are asked the difference between circular and non-circular shafts regarding torsion, you can explain with these 2 points. Now let us come to the torsion of general prismatic solid bars. So here we have to solve for the torsion problem of a general prismatic bar. It can be a circular bar, it can be an elliptical bar, it can be a rectangular bar, any random cross section. So we are going to the general derivation of the torsion of prismatic bars. So in the syllabus we have to solve for the torsion of circular and elliptical using Venant and using Parentals. So we have 4 problems, that is the circular section should be solved with Venant as well as Parentals, and the elliptical section should be solved with Venant and Parentals. Both these methods have these 3 things in common. First one is governing equation, second one is boundary condition equation, third one the equation for torque and the shear stresses. There will be only 2 shear stresses, tau Zx and tau Zy, which I will explain later. So let us have a look and comparison over Venant and Parentals method. If you learn the derivation, you will be familiar with all these equations of both the methods. If you are finding it difficult to learn the derivation, you have to at least by heart all these equations of Venant and Parentals method. As you can see, the governing equation, boundary condition, equation for torque, shear stress. We have these equations for Venant and Parentals method. I am not reading all these equations, you have to by heart all these equations, or we shall see in the derivation later. Now let us have a look at the Venant warping function. This was asked for 5 marks earlier. Describe the Venant warping function. Now what does warping means? Now let us take a random rectangular cross section. Now this is more or less a rectangular cross section. Now this section lies in the xy plane. This is your x-axis and this is your y-axis. Now this is the cross section of the shaft. The axis of the shaft lies along the z direction. Now this is the z axis of the shaft. Now if I apply an anti-clockwise torque, on this section, if I consider any point inside this section, now this may move like this in the anti-clockwise direction. Now what does warping means? Warping basically means the displacement in the z direction. Now after the application of the torque, now if I take any point, this cross section will move like this. Now in addition to the x and y displacements, now if this is moving like this, that means there is displacement in the x direction and y direction. Now in addition to the x and y displacement, if there is a displacement in z direction, that means the cross section, the tilting of the cross section, or the displacement in the z direction. Displacement in the z direction means it will move like this or it will move like this. That is, there is a displacement along z direction. There is a displacement in addition to the x and y displacement. This may move in the z direction also. So the warping means the displacement along the z direction. So let us look at the points. Warping is displacement in z direction. This warping displacement is a function of x and y only. It is independent of z axis. So it is a function of x and y alone. So what does uz means? Uz is the displacement along the z direction. So uz is equal to theta into psi of x comma y, where psi is called the warping function. It is a function of x and y only. Theta is equal to uz equal to theta into psi of x comma y, where psi is called the warping function. Now, if we analyze the derivation, we will obtain ux is equal to minus theta yz, uy is equal to theta xz. Now, let us look at a problem from Venant's warping function. You are asked to find out the twisting moment for shafts of non-circular cross-section incorporating warping function psi of x comma y. Remember, psi, if you see the sign psi, that is Venant's warping function. What is meant by warping of non-circular shafts? Prove that Venant's warping function is harmonic. So, I will explain the solution in detail. Now, due to shortage of time, I am just referring a textbook and I am trying to explain the concepts. Let us consider a non-circular shaft in which axis of the shaft is oriented along z direction and the cross section is oriented in the xy plane. So, this is the front view of the shaft. Remember, this shaft is non-circular and this is the axis of the shaft which is lying in the z plane, which is lying along the z direction. Now, I am applying an anti-clockwise torque on the shaft. I am applying an anti-clockwise torque T. Now, even though the axis is oriented along the z direction, don't confuse, I am taking the length of the shaft as z units. Now, let us see what happens if I apply a torque. Now, I am analyzing this point P, which is lying in the xy plane. So, P is defined by P of x comma y because it is lying in the xy plane. Now, I am applying a torque in the anti-clockwise direction T. So, this after the application of the torque, this P moves to P dash. Now, if I am defining this angle as beta, that is beta is the angle with which this line makes with the x-axis. Now, P moves to P dash. So, P moves to P dash, the displacement in the x direction I am defining by ux. Now, P moves to P dash, the displacement in the y direction I am defining as uy. Now, this R is the length from the origin towards the point P. If I am mentioning this point as O, OP length is R units. Now, if theta is the angle of the twist per unit length, for z unit length of the shaft, the angle of twist will be theta z. So, this angle will be theta z and my length P dash will be this dimension R into theta z. So, P dash will be R theta z. Now, this angle is beta. So, from the basic mathematical principles, I have this angle also beta. If theta is the angle between two lines, the angle between perpendiculars of those two lines also will be theta. So, by this principle, we have this angle beta. Now, let us analyze what is ux, what is the x displacement. So, x displacement will be now r theta z. If I resolve, I will get minus r theta z sin beta and uy is equal to r theta z cos beta. Why I am getting minus r theta z sin beta? Because P moves to P dash. So, this is the positive x direction. So, now the x displacement is in the negative direction. So, it is minus r theta z sin beta. So, P moves to P dash. This is in the positive y direction. So, it is maintained as positive only. So, ux is equal to minus r theta z sin beta, uy equal to r theta z cos beta. Now, from the figure, what is sin beta? Sin beta is equal to y by r. Now, what is cos beta? Cos beta will be x divided by r. So, we have sin beta equal to y by r and cos beta equal to x by r. So, substituting, we get ux equal to minus theta yz, uy equal to theta xz. So now what is UZ? So I have explained earlier, UZ means the displacement in Z direction, which is called warping. So warping means the displacement of the cross section along the Z axis. So I have explained earlier, it is a function of x comma y, where psi is called the warping function. So UZ, in addition to the x and y displacement, we have a displacement along the Z direction, and that is independent of Z, which is psi of x comma y. So in these two equations we have theta as common. So for UZ we add this common theta here, theta into psi of x comma y, UZ equal to theta into psi of x comma y, which is called the warping function. This function is independent of Z, and this represents the displacement in the Z direction. So if warping is asked, you have to explain the figure and you have to finally come to this point. Now let us move to the derivation of Venant's problem. So initially we check the strain components epsilon xx, epsilon yy, epsilon zz, gamma xy, gamma yz, and gamma zx. So if we substitute all these values, as obtained earlier, we will obtain only the value for gamma yz and gamma zx. All other components vanish. So we have obtained gamma yz equal to this equation, gamma zx is equal to this equation. Now let us move into the Hooke's law or the constitutive equations to obtain the stress values. Now even if you don't know all these equations, you have to understand that we will get sigma xx, sigma yy, sigma zz, and tau xy equal to 0. So how do we get 0? By substituting all these values in the constitutive equation, we will get the first 4 values of stresses as 0, and we will be obtaining only 2 values for stresses, that is tau yz and tau zx. So tau zy or tau yz equal to g theta into dou psi by dou y plus x. Tau zx is equal to g theta into dou psi by dou x minus y. Now next we are moving on to the equilibrium equations. We are checking the equilibrium equations. Automatically the first 2 equations are satisfied, and the third equation will give us g theta into dou square psi by dou x square plus dou square psi by dou y square equal to 0. That means del square psi is equal to 0. Since g theta cannot be 0, this term should be 0, del square psi equal to 0. So what does that mean? That means this function psi satisfies the Laplace equation. So that means the function psi is harmonic. This is which is asked in question paper. Prove that psi is harmonic. Now let us move into the boundary conditions. So for boundary conditions, you have to check the Cauchy's equation. Tx, here it is mentioned as fx. Why it is mentioned as fx here? Because in the boundary, force and stress are the same. So fx is equal to nx sigma xx plus ny tau xy plus nz tau xz. So if you apply the boundary conditions, you don't go for these complicated figures and all. If somebody is feeling difficulty, by applying the boundary conditions, you are getting the boundary condition as dou psi by dou x minus y into dy by ds minus dou psi by dou y plus x into dx by ds is equal to 0. So this equation you need to know. So let us analyze what is the torque. So T is equal to double integral tau zy into x minus tau zx into y dx dy. So how does this come? So as I have explained earlier, we have only 2 stresses. All other 4 stresses values are 0. Only tau zx and tau zy. So tau zy into dx dy gives the force. This force into perpendicular distance gives the torque. So tau zx into y, so this is acting in clockwise direction. So tau zx into y I am maintaining as negative. Now tau zy into x, this is positive direction, that is anti-clockwise direction. I have taken it as positive. So T is equal to double integral tau yz x minus tau zxy dx dy. So if I simplify this equation, I will get in this form, whereas you have to by heart the value of j. J is equal to double integral x square plus y square plus x dou psi by dou y minus y dou psi by dou x dx dy. So you can write this equation, and you can write T is equal to g theta into double integral this value, where double integral this value gives as j. So we have explained the Venant's derivation. Now let us see the summary of Venant's derivation. Now Venant's derivation is not asked in complete in previous question papers, but it was asked to prove that the Venant's function psi is harmonic. That's why I explained the derivation. So first of all, you have to explain the warping function psi. and you have to draw the diagram and obtain the displacements, expression for ux, uy and uz, and then you have to proceed to find out strains from the displacement, and we will find that there are only two strain components, and further by substituting in constitutive equations we will find out the stresses. The first four components are 0, only tau zx and tau zy exist. You have to learn the expression for tau zx and tau zy also. And after that we are proceeding into the equilibrium equation. The equilibrium equation, there are three equations, equations 1 and 2 vanish, and the third equation will give del square psi equal to 0, which means that the function psi is harmonic. Now we will proceed to Cauchy's equation. You remember in the boundary the stress is equal to force, and when no external forces are applied, the F is equal to 0. Substituting the values for stresses in the Cauchy's equation, we will get the boundary condition. Hope you remember the boundary condition, dou psi by dou x minus y into dy by ds minus of dou psi by dou y plus x into dx by ds equal to 0. Now after that we are moving to find out the torque T is equal to gj theta, where we are finding out the expression for j is equal to double integral x square plus y square plus x dou psi by dou y minus y dou psi by dou x dx dy. Now let us move to the Prandtl's derivation. I am not explaining in detail on the derivation. Let us see the basic steps so that you can attempt at least the very relevant points. So in the Prandtl's derivation you have to repeat steps 1 and 2 as you have explained in the Venant's. Now from the Venant's theory we know that there are only two stress components, because the initial four stress components, that is sigma x, sigma y, sigma z and tau xy are 0. So there are only two stress components, tau zx and tau zy. Now we are assuming a stress function phi, which is called the Prandtl's stress function. It is a function of x and y only, in such a way that tau zx equal to dou phi by dou y and tau zy equal to minus dou phi by dou x. Remember, this is phi, this is not psi. So tau zx equal to dou phi by dou y and tau zy equal to minus dou phi by dou x. If you substitute this in the equilibrium equation, you can see that we have taken this value in such a way that the equilibrium equation 3 is automatically satisfied. You can see equilibrium equation 1 and 2 vanish. So how did we get the value for tau zx and tau zy? We have taken the value for tau zx equal to this and tau zy equal to this in such a way that equilibrium equation 3 is automatically satisfied. Now since there are only two stress components, all the initial four strain components are 0. Now what is gamma yz? Tau yz by g. Gamma zx is tau zx by g. You should not confuse tau zy and tau yz because both are same. We are trying to derive the governing equation of the Prandtl's method. Tau zx equal to dou phi by dou y, which is equal to g theta into dou psi by dou x minus y. This is the function which we have obtained during the Venant's method. So we are equating these two functions. So now if you differentiate this with respect to y, we will get dou square phi by dou y square, which is equal to g theta into dou square psi by dou x dou y minus 1. Similarly, you have to write down the expression for tau zy and differentiate in such a way that we will get dou square phi by dou x square equal to g theta into minus dou square psi by dou x dou y minus 1. Now if we add these two components, what we will obtain? We will obtain del square phi. Del square phi equal to dou square phi by dou x square plus dou square phi by dou y square, and if we add these two quantities we will get minus 2g theta. So del square phi equal to minus 2g theta is the governing equation of the Prandtl's method. Now the boundary condition, you have to just learn d phi by ds equal to 0, which means phi equal to 0 on the boundary. The derivation is a bit complicated, so let us not move into the derivation. You just need to learn that boundary condition d phi by ds equal to 0. Most importantly, phi equal to 0 on the boundary. Now let us look into the torque. So for obtaining the torque, you can view this diagram. As we have explained earlier, there are only two stress components. Now we are applying the torque in an anti-clockwise direction. So tau zx into area into perpendicular distance gives a torque in the clockwise direction, and tau zy into perpendicular distance into area gives a torque in the anti-clockwise direction. So which means tau zx into dA into y is negative and the next one is positive. So T is equal to this expression. You substitute for tau zy and tau zx in terms of Prandtl's stress function. Remember that Prandtl's stress function is represented by phi. So if you substitute and the calculations are a bit complicated, you will finally obtain T is equal to 2 double integral phi dx dy. So you can write down this equation, you have to substitute and you can just write T is equal to 2 double integral phi dx dy. Now let us look at a previous university question from the warping section, Venant's warping section, where given psi equal to constant, you are asked to check whether the given function is a possible warping function or not as per Venant's method. Now you are asked to find out the shape of the cross section, the torsional rigidity, angle of twist, and the stress components and the resultant stress. Now this is a problem from Venant's torsion method. So you have to know the basic equations, the governing equation, del square psi equal to 0, boundary condition, equation for torque T is equal to gj theta and j is equal to double integral of this equation, and the shear stresses. This is very important. Tau zx g theta into dou psi by dou x minus y, tau zy equal to g theta into dou psi by dou y plus x. Now let us move into this problem that given psi equal to constant, psi equal to constant. So I have solved this in 4 steps, step 1, step 2, step 3 and step 4. So first step is to apply the boundary condition. So what is our boundary condition? Dou psi by dou x minus y into dy by ds minus dou psi by dou y plus x into dx by ds is equal to 0. So when psi is a constant, these two components vanish. So we will get the equation y dy by ds plus x dx by ds is equal to 0. Now I can write this equation as d by ds of x square plus y square by 2. So if I differentiate this equation, 1 by 2 is taken outside, 1 by 2 into d by ds of x square plus y square. So d by ds of x square will come as 2x into dx by ds. D by ds of y square will come as 2y into dy by ds. So this equation will yield this equation. So d by ds of this equation. Now what is this ds? ds means it is a portion of the boundary. S is a portion of the boundary. So d by ds of this term equal to 0 means this term is a constant. So x square plus y square equal to constant. So x square plus y square equal to constant represents a circular problem. So psi equal to c. We have started from the assumption psi equal to c. So psi equal to c represents this problem of a circular section. So our first question is to determine the shape of psi equal to c. It represents a circle. Now the second question is to find out the torsional rigidity of the prismatic bar. Prismatic bar in the sense, initially they have given psi equal to c. Now we have derived that psi equal to c represents a circle. So the torsional rigidity of the circle, we have the equation T is equal to g theta into j. Remember, torsional rigidity is equal to gj, where j is equal to double integral x square plus y square plus x dou psi by dou y minus y dou psi by dou x dx dy. So here you have to see that if I replace dx dy as dA, I can replace this double integral as single integral. Both equations are correct only. Now this double integral is replaced by single integral and I am replacing dx dy as dA. So if I simplify this equation and if I apply, now this dou psi by dou y will be 0. Why? Because psi is a constant. This dou psi by dou x will be 0 because psi is a constant. I will get the equation j is equal to integral x square dA plus integral y square dA, which is equal to Iyy plus Ixx, which is equal to Iz or Ip or j, which is the polar moment of inertia pi d raised to 4 by 32. Why pi d raised to 4 by 32? Because this section is a circle. Now theta is equal to T by Gip or T by Gj. Now you are asked what is the torsional rigidity. Torsional rigidity is equal to G into J. J you have obtained pi d raised to 4 by 32. So torsional rigidity is equal to G into pi d raised to 4 by 32. Now the next question is to find angle of twist per unit length. Now from this equation T is equal to G theta J, theta is equal to T by Gj. Now instead of J I have written T by Gip. So T by Gip you can replace Ip as pi d raised to 4 by 32 and you can simplify this equation. Now sometimes you will be asked what is a warping displacement, you said. Now while describing warping, I have said uz equal to theta into psi of x comma y. So here psi of x comma y is a constant c. So theta into c. So what is theta? We have obtained T by GIP. So T by GIP into c. Now the fourth question, stress components and the resultant stress. Now this diagram is for the sake of understanding only. This is not really required. As I have explained earlier, we have only two stresses, tau zx and tau zy. So tau zx into area into perpendicular distance y gives the torque in clockwise direction. Tau zy into area into perpendicular x gives the torque in anti-clockwise direction. So this is not required. I have drawn for your understanding only. So from the equation tau zy equal to g theta into dou psi by dou y plus x. So this term will be 0 because psi is a constant. We will get g theta x. So theta we have obtained as T by GIP. So gx into T by GIP we have obtained Tx by IP. Now tau zx is equal to g theta into this equation, which will yield minus Ty by IP. So what is the resultant stress? Tau is equal to root of tau zx square. Tau is equal to root of tau zx square plus tau zy square. So which will give you tau is equal to Tr divided by IP. Now from this we can understand that tau is proportional to the radius since T is a constant and IP is also a constant. So the value of shear stress will be maximum at R is equal to R max, which is the outer surface of the shaft. So tau is equal to Tr divided by J. Now let us look at another problem in which you are asked to solve the torsion problem of an elliptical cross section using Venant's method, and here angle of twist is asked, also stress components and resultant stress are asked. Now let us look into this problem. Here we have to assume that psi is equal to AXY. Now we have to start from this equation, psi is equal to AXY. So I hope you might be remembering the steps. The first one is to apply the boundary condition. Let us apply psi is equal to AXY in this boundary condition, which will yield ay minus y into dy by ds minus ax plus x into dx by ds is equal to 0. Now here, after rearranging the equation, you can take this y outside. So y into a minus 1 into dy by ds minus x into a plus 1 into dx by ds is equal to 0. And after further rearrangement, we will get 1 plus a into x dx plus 1 minus a into y dy is equal to 0. Now if we integrate this equation, we will get 1 plus a into x square by 2 plus 1 minus a into y square by 2 plus constant is equal to some constant. So we will take all the constants to the right hand side of the equation. So the denominators will move, the constant denominators will move to the RHS of this equation. So 1 plus a into x square plus 1 minus a into y square is equal to k, some constant k. Now if I further rearrange this equation, x square by k divided by 1 plus a plus y square by k by 1 minus a is equal to 1, which is similar to the equation of the ellipse x square by a square plus y square by b square equal to 1. What does that mean? That means psi is equal to AXY, which we have assumed earlier represents the torsion of an ellipse. Now, equating the similar terms. Now, this represents a square and this represents b square. So, what is a square by b square? Which is equal to k by 1 plus a by k by 1 minus a. Now, if we simplify this, we will get the value for the constant a is equal to b square minus a square by a square plus b square. Now, if we substitute the value for a in psi is equal to AXY, we will get psi is equal to this equation. Now, this is very, very important. We need this term to proceed further into the problem. Now, second step, you have to go for the torsion equation T is equal to Gj theta, whereas J is equal to integral x square plus y square plus x dou psi by dou y minus y dou psi by dou x dA. So, now we are substituting the value for psi here and we are differentiating to obtain this equation as J is equal to integral x square plus y square plus ax square minus ay square dA. Now if I further rearrange this equation into this form, so integral 1 plus a into x square dA plus integral 1 minus a into y square dA. So 1 plus a is a constant term. If I take outside 1 plus a into a integral x square dA plus 1 minus a into integral y square dA. So, integral x square dA represents Iyy and integral y square dA represents Ixx. So, I will obtain J is equal to 1 plus a Iyy plus 1 minus a Ixx. So, the equations for Iyy and Ixx for ellipse I have mentioned here. So, how to remember this equation? Now, y is the minor axis So in this equation, you have to cube the corresponding variable of the major axis. So Iyy is equal to pi a cube b divided by 4 and Ixx is equal to pi ab cube divided by 4. So from this equation, after further simplification, we will obtain j is equal to pi a cube b cube divided by a square plus b square. Now this is very important. J is equal to pi a cube b cube by a square plus b square. Now t is equal to g theta into j, which is equal to g theta into this value of j we have substituted here. Now from this I can find out what is the value for theta. Now sometimes they will ask what is the torsional rigidity. The torsional rigidity is equal to Gj and you have to write the equation accordingly. Now sometimes they will ask what is the displacement. Now displacement is equal to uz is equal to theta into psi of x comma y. Now what is this psi of x comma y? We have taken as axy, theta into axy. So this value for a we have found out earlier. You can substitute the value for a here and you can write accordingly. Now the last portion, they have asked for the shear stress and the resultant shear stress. As I have explained earlier, we have two values for shear stress, that is tau zx and tau zy. So what is tau zy? This equation you need to rememberize. G theta into dou psi by dou y plus x. You have to substitute the value for psi here and you have to differentiate and you have to obtain the final equation as 2tx divided by pi a cube b. Now what is tau zx? Similarly, g theta into dou psi by dou x minus y, which will yield you minus 2ty divided by pi ab cube. Now what is the resultant stress? Tau is equal to root of tau zx square plus tau zy square, which is equal to 2t divided by pi ab into square root of this term. Now if I take the LCM, I'll get the common equation as this one. Now the resultant stress tau is equal to 2t by pi a cube b cube into square root of b raised to 4x square plus a raised to 4y square. Now sometimes you will be asked what is the maximum value of shear stress. So for knowing that, you need to know what is the point which gives you the maximum value of shear stress. So you have to know that, let us not complicate, tau is equal to tau max at the end of minor axis, that is at y is equal to b for an elliptical cross section. So tau is equal to tau max at y is equal to b. Now you cannot substitute directly y is equal to b here because there are two variables. Now x is one variable and y is another variable. So you have to substitute x in terms of y so as to substitute y is equal to b. Now let us see. So tau is equal to 2t by pi a cube b cube into b raised to 4 into, I am substituting for x square as a square into 1 minus y square by b square. That is x square by a square plus y square by b square equal to 1. From that I can substitute the value for x square as this plus a raised to 4y square. Now you can see only one variable is there in this equation. We have removed the variable x from this equation before substituting the value for y. Now tau is equal to tau max at y is equal to y max, that is at b. Now if you substitute y is equal to b, you will get tau max is equal to 2t divided by pi ab square. Let us look another problem in which you are asked to solve the torsion problem of a circular cross section using Prandtl's method. You are also asked to find out the stress components and the resultant stress. So before proceeding to the Prandtl's problem, you need to know the basics, that is the governing equation is del square phi is equal to minus 2g theta and the boundary condition is phi equal to 0 on the boundary. And the equation for torque T is equal to 2 into double integral phi dx dy. What is phi? Phi is called the Prandtl's function. What is tau zx? Tau zx equal to dou phi by dou y and tau zy equal to minus dou phi by dou x. I have explained earlier that only two stress components exist in the torsion problem of a prismatic bar. Now before proceeding to the problem, I will simply explain what are the basic steps which need to be followed for solving the circular cross-section problem using Prandtl's. So first one, we have to write this equation of the circular cross-section in standard form before proceeding to Prandtl's problem. So we have the equation x square plus y square equal to c square. You have to take care that you should not write r square here because you will come to know why I have told like that later. So you have to take care that you have to write x square plus y square equal to c square right now, not r square. So let us take the c square to the LHS. So x square plus y square minus c square equal to 0. This is the standard form of the equation before proceeding to the Prandtl's problem. That is RHS you have to maintain as 0. Now the next step is to apply it on the boundary condition, that is phi equal to 0 on the boundary. We have the boundary condition phi equal to 0 on the boundary. So which means now this is also 0, which means phi equal to some constant m into this term. Phi equal to m into x square plus y square minus c square. So this is the standard form of phi before proceeding to the Prandtl's problem. We are writing down the Prandtl's function phi equal to some constant into this equation, LHS of this equation. Phi equal to m into x square plus y square minus c square. Why? Because phi equal to 0 on the boundary. Now let us apply the governing equation, that is the third step, del square phi equal to minus 2g theta. Now why we are doing that? We are doing that to obtain the value for the constant m. And after obtaining the value for constant m, you are again writing the equation for phi by substituting the value of m obtained herewith. Now the fourth step is to find out the stress components. I have told these are the ready-made equations of tau zx and tau zy, which you need to know, and the stress is tau is equal to root of tau zx square plus tau zy square. So this value we will obtain while solving the problem. I will explain very soon. Now the fifth step is to find out the torque. So T is equal to 2 double integral phi dx dy. So the equation for phi we have obtained. Now all these things I will explain very shortly while explaining the problem. Now let us see how to solve the torsion problem of a circular shaft using Prandtl's method. The basic steps we have seen earlier. So first step is to write down the equation in standard format, that is to maintain RHS as 0. So x square plus y square minus c square equal to 0. Remember, you should not write r square here right now. Now the second step is to write down the equation for phi. Phi is equal to a constant m into LHS of the earlier equation we have obtained. Why? Because phi equal to 0 on the boundary, where m is a constant. Now the third step is to apply the governing equation del square phi equal to minus 2g theta. What is del square phi? Dou square phi by dou x square plus dou square phi by dou y square equal to minus 2g theta. From that we have obtained m equal to minus g theta divided by 2. Now after obtaining the value for m, you should substitute it back in this equation to obtain phi equal to minus g theta by 2 into x square plus y square minus c square. Now next move to the fourth step to find out the stress components. As we have the equations, ready-made equations, we have tau zy is equal to this equation and tau zx equal to this equation. So we will get minus g theta x and g theta y respectively. So the resultant shear stress will be root of tau x z square plus tau zy square, which will be root of g theta, which will be g theta into root of x square plus y square, which is equal to g theta into c. So let us determine the torque of the circular cross section using Parentals. So T is equal to 2 double integral phi dx dy. So the equation for phi we have obtained earlier, and if we substitute the equation for phi here, we will get minus g theta into x square plus y square minus e square into dx dy. Now let us look at this figure. Let us consider a small differential ring of thickness dr as shown in the figure. Now this radius is small letter r and capital R is the outer radius of the circle. Now if I substitute x square plus y square equal to small letter r square and dx dy equal to dA, which is equal to 2 pi r dr. 2 pi r dr is the area of the differential element. Now T is equal to minus g theta. Where do I integrate? I integrate from 0 to the outer surface of the shaft, that is capital letter R, into r square minus c square 2 pi r dr. Now after basic integration, and by putting c square equal to r square. Why do I put c square equal to r square? Because at the outer surface of the shaft, c becomes capital R. So we will get T is equal to g theta into 2 pi r raised to 4 divided by 4. Now if I put r equal to d by 2, I will get T is equal to g theta pi d raised to 4 by 32. So this quantity pi d raised to 4 by 32 is a polar moment of inertia which is represented as J. So T is equal to Gj theta, or the torsional rigidity Gj is equal to T by theta. So now what is tau max? The maximum shear stress is at the outer surface of the shaft, which is at capital R. So tau max is equal to TR divided by J. So let us see how to derive the equation for components of stress, resultant stress and torsional rigidity of an elliptical cross section using Parentals. It was asked for 10 marks. Now solution of ellipse, a Parentals method. So first step is to write down the standard form of the equation of the ellipse. What is the standard form? You have to maintain the RHS as 0. So x square by a square plus y square by b square minus 1 equal to 0. Now second step is to apply it on the boundary condition phi equal to 0 on the boundary. So phi is equal to some constant m into LHS of the earlier equation obtained. So phi is equal to m into x square by a square plus y square by b square minus 1. Now third step, you have to apply the governing equation del square phi is equal to minus 2g theta. What is del square phi? Dou square phi by dou x square plus dou square phi by dou y square equal to minus 2g theta. So you have to differentiate and you have to obtain the value of m as minus a square b square divided by a square plus b square into g theta. So once we obtain the value for m, let us back substitute this value for m in this equation. So phi is equal to this value into x square by a square plus y square by b square minus 1 into g theta. So once you obtain the value for m, you have to substitute this value for m in the equation given here. So after substituting, you will get the equation of phi as this. Now in the question paper, now you are asked to find out the torsional rigidity. So let us go into the torque equation. T is equal to 2 double integral phi dx dy. So the equation for phi we have obtained as above. So if you substitute this equation, we will get the equation in this format. Now if we rearrange this equation in such a way that you can substitute the values of Iyy, Ixx and pi ab as shown here. So T is equal to minus 2g theta a square b square by a square plus b square into this term. Now if you carefully analyze, double integral x square dx dy is Iyy, double integral y square dx dy is Ixx, double integral dx dy for an ellipse is pi ab. So if you substitute, we will get this equation minus 2g theta into a square b square by a square plus b square into 1 by a square Iyy plus 1 by b square Ixx minus pi ab. You can see here Ixx is equal to pi ab cube by 4, Iyy equal to pi a cube b by 4. Integral double integral dx dy equal to pi ab. So by substituting, we will get T is equal to pi a cube b cube by a square plus b square into g theta. This equation is very important. Now from this we will obtain the angle of twist as theta is equal to this equation. Now in the question paper, it is asked what is the torsional rigidity. Torsional rigidity is equal to Gj, which is equal to T divided by theta. So if you divide this equation by this equation, you will get the torsional rigidity. Now g theta equal to T into a square plus b square by pi a cube b cube. Now if we substitute for phi in the earlier equation, we have obtained phi is equal to this equation. Now if you substitute for g theta as this term, we will get the simplified form of phi as minus t by pi ab into x square by a square plus y square by b square minus 1. Why I have done like this? Because the next step is to find out the shear stresses. I have to differentiate phi with respect to x and y. So if I have to differentiate, I have to simplify the equation. So for this only, I have substituted for g theta as this in the equation of phi. So tau zx is dou phi by dou y and tau zy is minus dou phi by dou x. You will get the values, and tau is equal to root of tau zx square plus tau zy square, which is equal to this equation. Now sometimes you will be asked what is tau max. So as I have explained earlier, tau max for an ellipse is at y is equal to y max is equal to b. but that you cannot directly substitute here. I have already explained earlier, you have to replace this x square in terms of y. So x square by a square plus y square by b square equal to 1. So from that you have to substitute for x square, which I have already explained in the Venant's method for solution of elliptical problem. So tau max, the value you will obtain 2t by pi ab square.